Okay, yesterday we did, how much work was tension? 6,000. How much work was done by friction? Negative 4,000. Gravity did 0. The net work we found was 2,000 joules. That was all yesterday. Continuing on, how fast is the box going to go after 20 meters to start from rest? So, here we go. So, big picture, force affects energy. If you have a force acting on an object, that's going to affect how much energy something has. You all right with that? Is that all right statement? General, like if a force acts on an object, it's going to cause it energy to change. Okay. So then the follow-up question is, well, yes, but by how much? And that is where work comes in. Work can tell us how much energy is going to change if there's a force acting on it. Okay. And that's where this work energy theorem comes in and is so important. Or, I don't know, important but powerful. Okay. So the net work you can either find from the way we did it yesterday is the total force acting parallel to the direction of motion times distance. That equals net work. Net work is also equal to the change in kinetic energy. It ties force and energy together. You all right with that? Okay. So last night you learned that kinetic energy is equal to 1/2 mass times speed squared. Okay. Can't remember. Was there a distinction between this V and that V in the video last night? This is for velocity. This is for speed. Okay. What's the difference? Tell your neighbor. What's the difference between speed and velocity? What do you say? Velocity has direction. Speed does not. Okay, velocity is speed and direction. Speed is, well, just speed. Okay, that's how fast. So this change in kinetic energy, so you have final minus initial. Okay. Now the fact that it starts from rest, how does that impact this problem? What can we do with that information? Crickets. Elliot. Put 0 in for initial kinetic energy. Why would I want to put 0 in for initial kinetic energy? Because it's influenced by speed. Does that make sense? Okay, if your speed is 0, then your kinetic energy is also 0. Okay, so this initial kinetic energy is 0. Bless you. Okay, so we have discerned already that the net work is equal to 2,000 joules from yesterday. 6,000 joules from tension, negative 4,000 joules of work by friction. Add those together, positive 2,000 is equal to 1/2 mass times speed squared final minus 0. I mean, you don't have to put the 0. I'm just trying to teach you. Okay. So 1/2 50 kilograms times final speed squared equal to 2,000. That becomes 25. So 2,000 divided by 25 equals speed squared. And that equals the square root of 80, which is equal to 8.9 meters per second. All right, with that. Questions on how I got, where I got, what I got. Okay. Truth be known, we could solve this problem before this chapter. Draw a free body diagram. Sum of forces in the x direction, in the y direction. Solve for acceleration. Take that acceleration and stick it in the kinematic equation and find the same answer, 8.9 meters a second. True, valid, works. Okay. What we're looking at is a different way to calculate the same thing. That's stupid. Seems redundant. Why would we want to do something like that? It works in this case that you can go either way, but there are definitely a lot of cases where free body diagrams and kinematic equations break down where the work energy theorem can still plow through. It's like, got this, no problem. Okay, so I'm going to encourage you to go the work energy route. Okay, sound good with that? Questions there? Okay, I'm changing up this scenario to a different box. Give that one a shot. Thumbs up when you have an answer. How about now? Thumbs up if you have an answer. Okay. There's two different routes to get to network. You can take it from the force times distance route. You can also take it from the change in kinetic energy route. Did you have enough information to solve it from the force times distance route? All you knew was the 40 degrees. You knew the mass, but that didn't really help you. Okay, so you're at a loss in this approach. But changing kinetic energy, you've got enough information for that. Okay, things that I wanted you to see. Number one, it's not just a final kinetic energy, it's the change in kinetic energy. Okay, so you need to take one half mass times speed squared, the final speed minus one half mass times speed squared. Okay, here's another popular error. Do not subtract these two and then square them. Okay, order of operations says does not work. So I get 450 here minus 50, 400 joules. How do we do? Good with that? Okay. Any questions there? Okay. Next question. Just a follow-up, same scenario, follow-up question though. Talk to your neighbor. Correct answer is? No go. What can you calculate? The net force. Okay? Please make a distinction between the total force and an individual force. This would work if only tension was acting on it. If the only force doing work was tension, then this would be valid. But because there's more than one force doing work, you can't find an individual force from this. I would need to tell you how much friction there was or something to let you figure that out. That makes sense? The whole point of this question, this finds the total force, not an individual force. Okay? Talk to your neighbor. Okay. Correct answer is? Got a C on the table. C. C. Correct answer is C. Okay. So, two different approaches. Network being negative. So in this scenario, your network is force of tension in the x direction minus friction times distance. In order to make this negative, friction needs to be greater than tension. Okay? And from this approach, initial kinetic energy needs to be greater than final kinetic energy to make this side negative. What would cause that to happen is if it was slowing down. Good with that? Okay. So work energy ties some things together pretty quickly. Okay. All right. Chew on this one for a little bit. Have a conversation.
So they're like, but they're like after. I still got it. I don't think that. I've been because I left her in charge. I did not know people make it in the script. They keep it at 10. I'm texting her. She's not responding. Like, mom, every car. She can take it. Our car is like.
It's on the desk. Maybe.
All right. Ready? Do what? Good. Okay. Well, that is the that is the important question. All right, let's take it one at a time. Let's look at the total force. Was there acceleration? Was inertia doing what it wants to do? No. Was there a change in velocity? From this point to this point. Was there a change in velocity from this point going north to this point going south? Yes. Why? There had to be a change in direction. Does velocity have direction? Yes. Okay. So, based off of all those answers, the total force, the net force, cannot be equal to zero. So correct answer is yes for one. The net force is not equal to zero. You good with that? Okay. Now, does energy have direction? No. That is a huge characteristic of energy that is different than what we've been studying. Okay? There's no direction associated with energy. We're looking at speed. This is kind of cool This is like a user-friendly equation. Let's say you forget and you're like put in negative 3 meters a second. Mathematically, you still get 9, positive 9 out of it. So that's pretty nice. Okay. So initially, you're going 60 miles an hour, and the direction, I don't care. Finally, I'm going 60 miles an hour. What was the change in kinetic energy? From initial to final, 0. There was no change. From initial, 60 miles an hour going this way, to 60 miles an hour going that way. Correct answer is the net work is equal to 0. Now, if your brain's going, that's good. Let me tell you why. When we're doing free body diagrams, we're taking the scenario at a moment, taking a snapshot. Hey, what forces are acting on it at this moment in time? Work and energy look at a process. Okay, so here's why the net work is equal to 0. As you're going down the interstate, 60 miles an hour, in order to turn around, what do you need to do? Slow down. Are my brakes doing positive or negative work as I'm slowing down? Negative. And then when I speed back up, is my engine doing positive or negative work? Positive. So by the time that I reach back up to 60 miles an hour, the negative work done by the braking is equal to the positive work done by the engine to speed it back up to 60 miles an hour. So from the process of starting at 60 miles an hour going north to 60 miles an hour going south, that whole process, the net work was 0. Some of that process was negative work. Some of that process was positive work. But overall, that process had 0 work. Net work was 0. It was a process. So it is imperative that you define, here's my initial and here's my final. Work is the process. It's force times distance. Thank you much. Okay. It's force times distance. So it's the distance. So it's force times the distance that the object moves. Good with that? Have a conversation.
So I think straight down. Is this like yeah. Oh, I don't think straight down. I think straight left. I thought you were. I think it was a curvy slide. I just went like straight down. No,
I smell a lawsuit on that.
I think it's like explode. No, yeah.
What do you say? I heard B's and C's. Any other? So between B and C, that's the difference. Is gravity doing positive or negative work? What do you say? Correct answer is positive work. FGX is going in the same direction as motion. Positive work. Good with that? All right. Call that good for today.